So we have, the next speaker is Heather Richard Smith, and she's the Vice President of Jacobs Connected Enterprise.
That's right.
Can you hold up the microphone because of the recording?
Oh, for the recording, I see.
It's not for
Okay.
applications, but it's for
Great.
recording.
Well, while the presentation is coming up, I'll just say I'm Heather Richard Smith, as you said. I lead innovation and what we call Jacobs Connected Enterprise for Jacobs. We are the largest engineering, architecture, and construction company in the world. Jacobs Connected Enterprise is our strategy for digital disruption. And I happen to be an alumna of the Civil Engineering Department, undergraduate and graduate. Here we go. Okay. So what I was asked to talk about is we had some really fantastic presentations this morning about a lot of the research that's being conducted in a variety of different areas. And what I was asked to present on is some of the more applied ways that this sort of advancement is being used. So I have a number of case studies that I will present to you. Please keep in mind that these are just a very small, brief sampling of some of the case studies. In fact, there's a much longer 90-minute version of this presentation that I'll be giving next week or 2 weeks from now at the American Society of Civil Engineers AEI conference. So just hopefully we'll give you an idea of some of the ways that you can apply this technology. And I apparently am not applying technology very well because I cannot advance the slides. Do I just use the arrow right here?
Yeah.
Here we go. Okay, so I'm just going to start out. We are a very safety-conscious culture within Jacobs, and so I can't start any presentation without a safety moment. And you think about some of the benefits that we get from digital disruption. One of them really should be safety. We ought to be making citizens' lives safer. So one of the things that we've done is to use virtual reality to train highway workers and prepare them for some of the hazards that they might face out on construction sites before they actually make it their way out there. So you can think of a lot of different ways that we can use digital disruption to help people be safer. I don't think anyone in this room would be here if you didn't recognize the fact that there's a lot of not only opportunity but also risk when it comes to digital disruption. And there has been a study that has suggested that 4 out of 10 market leaders will be displaced by digital disruption in the next 5 years. So all of us should be looking to make sure that our companies, our universities, our clients are being really not just insulated, but really trying to advance beyond that. And then one of the opportunities is that it's been suggested that digital disruption and digitization will generate $100 trillion worth of societal impact by the year 2025. But a lot of what we need to think about is that we need to take a balanced approach. If we're using technology and innovating just for technology's sake, I think we're really going to miss the mark. And even though that's really the exciting part, it's fun to really think about technology, we need to constantly be asking, what is the business model? How is it going to make sense for society, for culture, for people to be able to implement this technology? And then we also need to remember that we need to be asking, what is the customer demand? Does anybody here remember New Coke from the 80s? Yeah? That's an example of an innovation that was provided, and it was an absolute debacle. There were people who were importing old Coke from overseas. There were literally protests and boycotts. So we need to remember to ask ourselves, what is it that our clients want? And there will be sometimes, for example, sometimes with public sector, where they might not necessarily be ready, but we as innovators, we as academics, we as private industry can all be helping these customers to realize what it is that they need. So just very briefly so that you can understand kind of the lens through which we view all of this, Jacobs Connected Enterprise, JCE, is not like a standalone unit of people. You know, I always tell people we're not a group of digital ninjas who are going to come in and tell clients and people what to do on their projects. Rather, it's really a strategy for succeeding in an accelerating digital world. And it's a way of thinking about how to harness technology in order to enable better business decisions, so that you don't end up having a situation where, you know, we're not an engineering company that's just now trying to understand technology. We're also not a technology company that's just now trying to understand the built environment. We're able to bring it all together. So before I go into the case studies, I want you to understand, one of the things I was asked to do was to explain how, you know, one private sector company is approaching digital disruption. We're viewing it through 4 different solution areas, those 4 being connected mobility. You think about some of the connected and autonomous vehicles that were described this morning. Connected places, smart cities, future cities, pedestrian modeling, dashboarding, connected assets. So talk about the living lab earlier today. So using sensors to make better, more informed decisions about our assets. And then finally, connected delivery. How is it that we are delivering our projects? And it's very intentional that there are arrows going in and amongst all of these because it's a very fine line. Who's to say where connected mobility ends and connected places starts or ends as well? So to start out then with connected mobility. Again, I mentioned this is a lot of connected and autonomous vehicles, mobility as a service. The goal here is to reduce congestion, increase productivity, and facilitate the movement of people and goods. And here's where I'm going to really get into a lot more of the case studies. So, urban mobility. The City of London is expected to have tremendous population growth, possibly even doubling in size by the year 2050. So how is it that they are going to take their existing infrastructure and make the best use out of that infrastructure to handle all of the urbanization that she mentioned as well in terms of people moving into cities as well? So we are taking the data that's been collected from 400 million multimodal journeys. It's been collected from things like cycling apps and from GPS, mobile phones, smart cards, social media. And we're using this to find previously unattainable insight into crowd behavior. What this then will do is it will allow Transport for London, who maintains all these transportation assets, to make better predictions about where they need to be either expanding or maintaining or building new infrastructure and where they might be able to make better use with what they already have. It's expected or it's believed that this is the most comprehensive data set of its kind, and you can think again about a lot of the research that was presented this morning and how we can partner together to really advance transportation. Another connected mobility example is the use of dedicated short-range communication, or DSRC. We're doing this for Maryland Department of Transportation, or Maryland Transportation Authority. And so what this allows is that these wireless cell services, these units that are on onboard units in cars, they gather information on things like vehicle size, speed, direction, position. And they communicate with roadside units that are alongside the roadway that then inform the vehicles about traffic conditions. All of these OBUs, the onboard units, are being installed on state vehicles, and it's providing Maryland with a lot of information about how these DSRC radios can be used. It's providing research and statistical data that will really inform the regulations and allow this research to be able to be applied nationwide. And as a result, safety, I mentioned earlier, and roadway congestion is expected to benefit as well. And then you think about all the connected and autonomous vehicle technology that we talked about earlier. There's a need to find a safe and highly effective way to test this vehicle technology. So Florida Department of Transportation had need to develop, through their SunTrax project, develop a test track where these connected and autonomous vehicles can be tested. And so it's about 2.25 miles of oval track to test these vehicles at a variety of speeds, to include high speeds, variety of conditions, everything from smoke, fog, dust conditions, various settings. And it also allows virtual and augmented reality platforms so that you can really test under just about any scenario. So again, taking that research, academic sorts of things that we discussed this morning and putting it into a real-time, real-life applied example. So I'm going to just skip right into connected places now. A lot of people, we're in a smart cities session right here. We prefer the term connected places simply because there are a lot of places that aren't cities that would really benefit from these sorts of approaches. So parks, military bases, stadiums are really almost cities in and of themselves, but they might not consider themselves to be cities. The goals here are economic growth and to enhance, once again, as our prior speaker said, the quality of life for users and residents of those areas. One example that we have here is in India. It's the Amaravati Smart City Program Management. They were looking to try to integrate some of the critical systems within their city, things like water, security, power, transportation. And so we've helped them to use Internet of Things capabilities to really help these vital city functions communicate from one to the other. There's an app that the city has used, and this app allows the citizens to then gain real-time information about how the city is operating, and they're provided with reliable and up-to-date information about their city. A water application. We talked a little bit about flooding earlier today, and of course, combined sewer overflows are a big challenge in a number of cities. In the city of Cincinnati, they were looking to try to minimize the amount of wet weather overflows that they had from some of their very decentralized facilities. So using sensors, flow meters, gauges, they were all used with Internet of Things technology along with cloud technology to then enable the client, the Metropolitan Sewer District in Cincinnati, to then have very timely visualization of their flow conditions and then maintain and coordinate their wet weather control. We've been able to help them move to more of a predictive model so that based on past conditions, you can take a look at what wet weather is expected to now come into play, and they can then change the settings and reroute things so that they can then avoid future overflows. One of the, two of the really, I think, very critical outcomes of this technology that we've been able to implement for them is we've been able to prevent them from having to build about $300 million of new conveyance, storage, and treatment. And very importantly for the environment, this technology, by using the Internet of Things, has enabled them to decrease the amount of untreated and partially treated sewage that's released into the environment, the local waterways, by half a billion gallons. So again, an example of digital disruption, Internet of Things, cloud technology, data analytics, helping to improve the quality of life, improve the environment, increase safety, and all the rest. And for the city of Centennial, this city happens to be located in Colorado, and we have helped them with their parks, with their community development, transportation, solid waste, and all the rest, to really bring this city together in a smart city fashion. The goal to start out was to increase the level of service and, of course, the quality of life then for these residents by delivering very comprehensive public works for the citizens. We created a citizen response center so that the public works operations could be very responsive and proactive to these citizens. It really has helped to improve the customer service response times and engagement with the citizens. We incorporated intelligent transportation systems, and this of course helps with things like safety of the roadways, mobility, reliability, and improved efficiency for the residents. And one of the things that I think is really neat is that by using data analytics and a lot of new technology, we've reduced their snowplow route completion time by 40%. Or looking at it another way, we have helped them to plow 93 additional miles with no additional fuel consumption, no additional emissions. And all of this is using technology, using sensors, using data analytics, which of course you can imagine in a city in Colorado, snowplow operations are a very large consumption of time, of manpower, of emissions, and of fuel. So the third solution area is connected assets. This includes things like extending the life cycle of assets, moving to more of a predictive maintenance model, smart water. The goals here are to optimize not just the operations of the assets, but also to optimize the expenditures. So reduce the operating expenditures as well as the total cost of ownership. So really good synergies with the Link Lab, Living Lab here. For NASA Langley, this is a facility that's in Hampton Roads. We've been able to take them to more of a predictive maintenance model by installing 120,000 sensors across their entire campus. These sensors measure things like vibration, acceleration, temperature. All of this data then goes into an integrated operations center. And so instead of just, say sending a maintenance person out every 6 months to change a filter or a fan belt or whatnot, it's all based on predictive analytics, and we've been able to do this in a way that has saved the client money. It's really decreased the amount of unscheduled outages. This is a very, very energy intensive operation. We operate wind tunnels and all the rest, and so prior to implementing this solution, they were experiencing quite a bit of unscheduled outages, which for an installation like NASA is really a challenge. They lose a lot of revenue in terms of test revenue that occurs. So that's been one of the really big outcomes, we think, is decreasing that amount of unscheduled outages. And then another example here is using the Internet of Things to help on construction sites. So using our tool called ION, which is an Internet of Things platform that allows us to connect things like the material, the staging, the construction workers, the equipment. So when you use ION, gone are the days of having the workers having to wander around looking for certain equipment or trying to find out where a certain employee is from a safety perspective. Instead, all of this is tagged with RFID, and it allows for increased safety when it comes to mustering if there were to be an event on site. And it allows for improved efficiency because the workers are then a lot more effective in terms of them being able to find the equipment and the material that they need. And the results here are 100% materials availability on site. If you've never worked construction, you might not recognize the fact that in many cases, you can lose material and it ends up becoming damaged, so that 100% material availability is very important. 0 lost pipe spools, productivity improvements, and return on investment of 285%. So again, great example of being able to use digital disruption to help from an economic perspective. Next example is a digital twin example using a proprietary tool called Replica. This particular client happens to be a manufacturing client, but it's also been used for municipal water and wastewater clients as well. They were experiencing poor performance of their industrial water treatment system. So we came in, developed a digital twin for them, which allowed us to optimize the operations of their industrial water, leading to energy consumption decreases of 33% and decreases in the amount of chemicals that needed to be used as well. Another example is for connected assets and the use of structural health monitoring. So in this case, in Australia, there was a bridge abutment that had failed, a bridge abutment ground anchor that had failed. And so in the course of completing the rehabilitation design and construction, there was a need to monitor the site to make sure that there was no worsening of conditions and to make sure that the site remained safe for everyone involved. It was monitored 24/7 for about 18 months, and it actually did detect and then instantaneously notified us and our client of an issue so that safety issues could be avoided. And then finally, just the final solution area is connected delivery. This includes things like virtual and augmented reality, automated design, additive manufacturing, laser scanning, UAVs. Some of these technologies are not necessarily new and innovative anymore, but there is a need to not only advance where we're going with them, but also to implement them more frequently on a lot of different projects because not all areas, not all clients are currently comfortable with them. The goals here are to optimize delivery, improve efficiency, reduce schedules, improve quality and consistency, and then reduce the capital expenditures. This one is another example of virtual reality, the use of virtual reality to help with stakeholder engagement. So if anyone here has ever been involved in upgrade or a transportation scheme, you have to go out and do these community meetings. I know we've got our partners from VDOT here. And sometimes it's really difficult for the community to understand just by looking at a set of plans or by looking at some renderings. But we've helped to improve that community stakeholder engagement by using virtual and augmented reality, helping the public to gain better appreciation for what the final scheme will end up looking like. And we've found a lot of success with this in a variety of different areas. And then just last case study that I'll present right here, but certainly not the last that we have, but hopefully this is giving you just a flavor of what's possible. If you were at the demonstration area yesterday, you may have seen our booth and we had the 3D printed lunar habitat. I just think this one is so interesting and exciting because we have found a way to work with NASA to decrease the amount of material that needs to be shipped from the Earth for space travel by 60 to 90%. So as a result, it really means that we can help NASA to accelerate the deep space mission. And then the U.S. Army Corps of Engineers was also very interested in this because we could build their structures, things like barracks and guard shacks and all the rest, in expeditionary environments, war zones, in 20% of the time with less than half the people, half the material, which then means that people are out in harm's way for shorter durations. You don't have them being subjected to the risks of IEDs on the roadways and all the rest. But these aren't just, out of this world or war zone, applications. The state of Hawaii is interested in this technology. Dubai recently issued a goal of 3D printing a fair amount of their structures by 2025 as well. So just to conclude, this happens to be our philosophy when it comes to Jacobs Connected Enterprise, but I keep it here because I think it's very applicable to all of what we do when we think about how to try to apply this digital disruption and research in the real world, if you will. We're looking to try to enable smarter decisions and better business outcomes. We're looking to leverage global and diverse perspectives that span across, in our case, the Jacobs enterprise, but when it comes to the Link Lab, really spanning across the entire university. And we're looking to support digital transformation and help our clients thrive in the age of digital disruption. So what we're looking to do is to combine leading edge information and operational technology with deep domain expertise and intimacy to provide holistic solutions that help our clients make better business decisions. So with that, I don't know if you wanted to take any time I tried to catch up a little bit of time.
Yeah, okay.
Got us in a little under.
Some time for questions?
Yes. With the connected spaces, was there anything that was like a common denominator that enabled those cities kind of be ready to capture the value that, get the money for those projects? Was it financing, leadership?
All of the above, but I would say what we really feel is necessary, the common denominator that we really try to bring to these sorts of scenarios is really taking a step back and starting out with a master plan, because I think you mentioned earlier, it can be almost like just a dizzying array of options, and if you don't step back and prioritize and create a plan, you're not going to be effective in any of them. So really, I think that's probably the common denominator when it comes to success of these sorts of options, is taking a step back, preparing a master plan, and prioritizing not just the technologies that are available, but the goals and objectives and what's most important. Yes?
So if I understand it correctly, so it seems you are using a lot of so-called IoT to provide integrated solution for different cities. But we just heard that this gentleman told us that it's so difficult just to get one data standard so that interoperability can be reached. And so you mentioned like sensors and all that stuff. So let's take one. Sensors, the manufacturer could be from many different companies, and they could have a different data standard and all of that. So I'm really curious about your company as a private one. How do you take the leadership to kind of integrate different kind of data sources and hardware and software?
Right, that's a great question, because and I don't want to, I don't really want to take sides, if you will, right here, but what we really try to take the position of is being a technology integrator. We're not selling any one particular product. So our personal position is that it really is better to go with more of an integrator kind of approach, because if you end up going with a particular vendor, you can end up essentially painting yourself into a corner. So when we're helping clients to decide how they want to approach smart sorts of options, we really try to take it from the perspective of what will provide them the most long-term, what's the most longevity for their project, and in many cases that may be a more tech-agnostic approach. So that's the philosophy we try to keep. We're not selling any one particular product in order to avoid any kind of conflicts in that regard.
But I guess the question was how you handle the heterogeneity of the sensors and the different data types
Right.
in the system.
Yeah, so it depends on the individual project. The ION example that I provided, the construction project where we provide the IoT platform, that's a proprietary solution that we have that works with a variety of different vendors. So it doesn't just work with, say, I don't want to say any company names, but it doesn't work just with one particular vendor. It's intentionally tech agnostic so that we can integrate all of them, which allows our clients to be able to make use of their existing sensors as opposed to having to rip out and put everything else in new.
Okay, so why don't we thank Heather?
Sure.